Abdul, are you there in the class?
Yes,
So please turn on your camera
yes.
and tell me that how will you prepare baking soda? How will you prepare baking soda?
Sir, me baking soda,
Yeah,
NaCl plus
you
H2O.
are still looking into the copy. The same you were doing previously. Unmute yourself.
Okay, now I'll look at the camera and say, okay, NaCl plus H2O plus NH3 plus CO2 gives us,
Again you watch on the side.
huh?
Again you watch. There is a copy there. You watch like this. Your eye contact should be on the camera. Okay.
Na, NaH, NO3 plus
NH,
Na4Cl, Na,
NaHCO3
NaHCl, yeah,
or NH4Cl or Cl2.
Cl2. No, wait, no Cl2.
It is only Cl, NH4Cl. Yes. Yes, you Zainab, how will you prepare? Sorry, Alvina, how will you prepare caustic soda? And what's the name of the students? Arif Makbul. Are you there? Are you in the same batch?
Sir, I'm Aisha. I cannot change my name.
Aisha, please turn on your camera.
Yes, sir.
Yes, you tell me that Alvina, how will you prepare caustic soda? Alvina, you are muted. Can you tell me that how will you prepare caustic soda? Yes, Mariam, can you tell me that how can we prepare caustic soda?
When passing electricity on an aqueous solution of sodium chloride called brine solution, it decomposes to form sodium hydroxide and sodium hydroxide and carbon dioxide gas. 2 NaCl plus 2 H2O gives 2 NaOH plus H2O plus Cl2.
Yeah, this is very simple. Caustic soda, NaOH, NaCl plus water. When you pass electricity to it, when passing electricity to it, then it will gives you NaOH plus Cl2 plus H2. This will be produced at anode, and this will be produced at cathode. So, dear students, you keep revising the topics, okay? Otherwise, how? Yes, Alvina, can you tell me that how can we prepare bleaching powder? Alvina, is I audible to you? Yes or no? Alvina, are you there? Alvina,
Sir, your voice is not audible.
my voice is not audible. Rejoin it. Okay. So what I'm saying here is that uh yes, I just tell you. Okay. So what I'm saying here is that yes, you Abdul Kavi, can you tell me that how can we prepare baking soda? Sorry, bleaching powder. Bleaching powder. How can we prepare bleaching powder? Can you tell me how can we prepare bleaching powder? Bleaching powder. Abdul Kavi, is I audible to you?
Yes.
Yes, then why are you not answering? Can you tell me how can we prepare bleaching powder? Yes, Aisha, can you tell me that how can we prepare bleaching powder?
Sir, I did not revise, but I learned a little bit.
Okay. So can you tell me that how
Um,
can
Chlorine is produced during electrolysis of aqueous sodium chloride, which is also known as brine. Chlorine gas is used to manufacture the bleaching powder.
and how can we prepare bleaching powder now? How can we prepare bleaching powder?
By dry slated lime,
By passing chlorine gas to slag lime. Then it will give you what is the formula of baking soda? Sorry, bleaching powder. Yes, Alvina, can you tell me what is the formula for bleaching powder?
Calcium hydrochloride, CaO and Cl2.
CaOCl2. This is hydrochloride. Where is hydro H? Where is H? Calcium oxychloride.
Oh yeah.
Or calcium hypo, not hydro. Hypo
Okay.
plus water. H2. Okay, let's start the new chapter. That is first chapter of the chemistry. And that third chapter of the chemistry, that is the metals and non-metals. Okay. So let me start doing this one. Just a minute. Just a minute. Let me update topics for the students. Just a minute. Okay. So here, what are metals? Can anybody tell me that what are metals in the class? They that can anybody in the class can tell me that what are metals?
Metals are substances that conduct heat and electricity.
Okay, then
Um, they have the tendency to donate electrons.
okay, they have tendency to donate electrons. Okay. Another, they have the like for example, if I'm talking elements, we have broadly classified the elements into three broad categories. Elements has been broadly classified into three broad categories. One is metals, another one is non-metals, and the third one is metalloid that are intermediate. Actually, we can write it non-metals here. Metalloids are metals, then metalloids, and then non-metals, and then non-metals. Okay, what are metals? Metals are those elements that are going to have either one or two or three electron in their outermost electron in their outermost shell. Means outermost shell means the last shell. Okay, except we will say that except the hydrogen and helium. Hydrogen has one electron. Hydrogen and helium is a noble gas which has two electrons. Other element that has one or two or three electron in the outermost shell, the last shell. Okay. we are considered to be as metals. Second is non-metals are those elements that are going to have from 4 to 7, either 4, 5, or 6 or 7 electron in their outermost shell, outermost shell. Okay, outermost shell is last shell. Metals, since metals have every element wants to attain this, every element wants to attain this stable electronic configuration. Okay, like for example, there are some noble gases, helium that has electronic configuration 2. Another is neon that is electronic configuration 2,8. Then argon that is 2,8,8. Now, if an element has 2,8,2 electron in its outermost shell, so its nearest noble gas is this one. So it will lose electron. It will lose the 2 electrons. Got it? And like 285, it will gain the 3 electrons. It will gain the 3 electrons. So sometimes the element loses electron, sometimes the element gains electron in order to attain the stability, in order to attain the stable electron configuration to the nearest noble gas. Okay, like neon is a noble gas. It has completely first shell and second shell fill. It is first and third and first, second and third shell fill. So we'll say that sometime, like for example, if I'm talking example of oxygen, so oxygen has 2,6 electronic configuration. So it will gain 2 electrons, in order to attain the stable electronic configuration to that of neon. But what about sodium? Sodium is 281. So it will lose 1 electron in order to attain the stable electronic configuration to this one. So when an element lose 1 electron, it will acquire 1 positive charge. When an element gain electron, it will acquire the equivalent charge as the number of negative charge as the number of electron it has gained. Means, for example, if an element lose 2 electrons, so it will acquire 2 positive charge. But if an element gain 2 electron, it will acquire -2 charge. Okay. So we'll simply say here is that that elements are those substance. So metals are those substances that are either going to have 1 or 2 or 3 electron in their outermost shell, while non-metals are those substances that are going to have uh, uh 4 to 7 electron in their outermost shell. Non-metal is metal easily lose their electrons since they have 1 or 2 or 3 electron in their outermost shell, so they will lose their electrons easily, while the non-metal will gain electrons. Metal form electropositive ion after losing electron, while the non-metals form electronegative ion after gaining electrons. Third, and another one is that non-metals have low ionization energy. Ionization energy means tendency to lose electrons. So metal can easily lose electrons, so they don't require much energy. They can easily donate electrons. They can easily lose electrons because they don't have much energy. But if I'm talking about the non-metals, they are not electron loser. They try to gain electrons. So they generally gain electrons and they have low electron gain enthalpy. So just I'm going to give you 2 to 3 minutes to orally memorize this one, and then I will remove this slide and then you have to write this all in your own words. Okay, so note it down. No, means you are not going to note it down. You have to memorize it. Just memorize it, each and everything. And then I will remove the slide. Then you have to write it down in your own words. Aaron. When you done, then let me know. When you memorize, then let me know.
Sir, I didn't understand the last point of metal.
They have low ionization energy. We will discuss what is ionization energy. So they have low ionization energy.
Okay.
Done? Done? You, Mohammed Firdaus, and you Zainab, and you Aisha.
Yes, sir.
Not yet.
Not yet. Memorize it fast. Memorize it fast.
Okay.
Yes. So done? Okay. Start writing in your own words, please. Start writing fast. . Done. Noted.
Yes, sir.
Okay. You also, Mohammed Junaid Firdaus,
I'm still noting, still noting.
noted fast. Mariam, you noted?
Yes, sir.
Okay. Nalvina,
I'm noting, sir.
noted down fast. Okay. Yes, Zainab, read your answer, please.
Yes, sir. Metals are elements that generally have 1, 2, or 3 electrons in the outermost shell. They lose electrons to form cation. Metalloids, they have properties of both metals and non-metals. Non-metals, they are elements that generally have 4 to 7 electrons in their outermost shell. They gain electrons to form anion.
Anion and cation. Anion is
Cation and
cation is positively charged and anion is
negative.
negatively charged. So when non-metal gain electrons, so don't have written the in terms of ionization energy. Metals have low ionization energy while non-metals have low electron gaining enthalpy. Okay.
I didn't understand the last point, so that's why I didn't write it.
Okay. Albina, you noted?
Sir, I'm noting the non-metals. Last point I'm writing.
Okay, noted. Yes, you, Mohammed Firdaus, you noted?
The metals last point I noted, but non-metals last point I did not note.
Okay, no, check whether if you have match your answer if you have not done something. So match your answer, please. Except hydrogen and helium. Yes, you, Mariam, sorry, Zainab, you have missed this hydrogen, except exceptions of metals, hydrogen and helium.
So what does enthalpy mean?
Enthalpy means energy. Enthalpy means energy. Okay. So here we are going to have a question for you. And you have to answer me. What should be the answer for this question? Question number 30. Note down this question number 13 in your notebook fast. Done? Yes, what should be the answer for this question number 30, Mariam?
Sir, A. X is a metal.
X is a metal. Okay, it means you have not written that. I honestly tell me that did you write that thing? The previous chart that we were doing, the difference between metals and non-metals. Did you write that one, Mariam, in the copy?
Yes, sir.
Show me. Show it to me
Yes, sir.
with the camera. The back camera, show it to me. I think you are noted down. So your answer is incorrect. Yes, Mariam? Can you tell me? Sorry, yes, Ali. Aisha, can you tell me? What is the answer for this question number 30? Aisha,
Yes, sir.
can you tell me that what is the correct answer for question number 30? Mariam, this is X electronic
Sir, I
config.
don't understand.
You don't understand the question.
No, sir.
Okay. Okay. Yes, you, Alvina.
Sir, it's option D. Y is non-metal and Z is metal.
Y is non-metal and Z is metals. Yes, you, Junaid, sorry, Firdaus.
D.
Which one?
D. D.
B for ball. Y is a metal. Okay. Yes, you, Zainab. What is the what's answer for this question?
D. Y is a non-metal and Z is a metal.
D means yes, you, Abdul Kavi.
D.
C.
D.
A,
D.
B. D.
Yes.
Sure.
Yes.
Simple. This is very simple. Mariam, very. Just look at this, beta. I told you in the slides. That's why I told you to memorize this one. What I told here is that metals are those elements that are going to have either 1, 2, or 3 electron in their outermost shell, means the last shell. And non-metals are those substances that are going to have from 4 to 7, means either 4, 5, or 6, or 7 electron in their outermost shell. So if you go through this question, and you will notice here that X is going to have 8. And not 8 is 8 if it is the second shell, then it is a noble gas, neon. So X is a metal, it is incorrect. Y is a metal, is also incorrect. Why? Because Y is a non-metal. Why? Because it is going to have 7 electron in their outermost shell, last shell, 287. So last shell is 287. So 7 means non-metal. Metal can have 1 or 2 or 3. And Z is a metal because it is having 2 electron. So Y is a non-metal and Z is metal. You noted this answer, everyone in the class?
Yes. Yes.
Yes, sir.
Then why you commit
Yes.
mistake in this one? This was very simple. Where you are getting stuck in this question? This is a simple question. Next portion, if I'm talking to this one, is that here is the, if I'm going through this one, that is properties. Okay, properties of the elements or of metals. Like what are the physical properties of metals? Metals are those substances. Okay, they are generally going to have, because in this case, in the physical properties, mostly the exceptions are going to pass. That metals are going to have very high densities. Metals are very heavier in mass. Okay, like for example, if you have something like you have a Ludo dice. If a same Ludo dice is made up of iron, it will be heavier as comparison to that of the Ludo dice that is made up of wood, because wood don't have that much density as comparison to that of metal. So metals are going to have high densities. Like for example, if you have a Ludo dice and if it is made up of iridium, then it might have, let's suppose if that dice weighed 22.5 grams, then that dice that is made up of lithium, that is going to have only 0.5 grams weight. So we'll simply say here is that lithium is the lightest metal that is going to have very low density, and iridium is the heaviest metal that is going to have the very highest density. Okay. Understood? Yes or no?
Yes.
Next point, if I'm talking here, is that high melting and boiling point. High melting in boiling points. And this is tungsten that is have a symbol of W, had the highest melting point, and this because of metals have very high melting point. This is used in in making the filament of the bulb that glow red hot but does not melt because its melting point is very high. Second is gallium and cesium. These are the exceptions. Gallium and cesium are the metals that have very low melting and boiling point. They have the melting and boiling point near the room temperature. Means if you kept it on the palm, then rub it, it will melt on your palm. So simply say that gallium and cesium are the metals that can easily that have low melting points. Okay. Next one is generally solid, but mercury is liquid at room temperature. Generally, metals are solid, but mercury is the only metal that is liquid at room temperature. They are highly ductile and can be drawn into thin sheet. Malleability means can be drawn into thin sheet. When you hammer it, then they will easily get hammered and they can easily be broken into thin sheet. Means drawn into thin sheet. And ductility means that they can be drawn into thin wire. Means they can be so stretched and keep on stretching. Gold is the most ductile metal that even 1 gram of gold is enough to be drawn with a wire of length 2 kilometer. So gold is most ductile metal and malleable metal. Metals are generally shiny. They have shiny appearance. They are lustrous. They are very hard, but metals like sodium and potassium that are called alkali metals, they are so soft that they can be easily cut with the help of knife. They can be easily cut with the help of knife. They are hard. Metals are generally hard, but they are sodium, potassium are soft metal that if you cut it with the help of knife, they can be easily cut. And they are good conductor of electricity, as you know that they are shiny. The most shiny metal is silver. Silver is the most shiny metal. Gold is the most ductile metal. Okay. Tungsten is the highest density, highest melting and boiling point. Highest densities of iridium. So please memorize this one fast, and then you have to start writing in your copy. When first memorize it, and then let me know if you have done. Then we should remove this slide, and then you have to start writing. So memorize it fast.
All of this.
Yeah, all of this.
So what is written after they have high densities?
What is the reason that they have high densities? Because they have very the force of attraction between the particles of metal is very large, very high. That's why more number of particles will come. Like for example,
I mean, like, what is it written? Like, what's the word over there?
oh, what is the word over there? Iridium has highest density, that is 22.5 gram per centimeter cube.
Oh, okay.
Like water has 1 gram per centimeter cube. Like for example, if you have 1 kg of ice, 1 kg of ice, 1 kg of ice might be like this one. If you make the same amount of
Sir, for ice, we say kg or liter.
for ice,
Yes.
will take means 1 kg. If I'm just saying that you have a can take because it is grams. I'm just talking about the grams per centimeter cube. Na? So if I'm talking about the ice, if you take an ice cube which is having a mass of 1 kg, and if of same dimension, if you take the iridium, it will be weighing 22 kg 0.5 grams, 150, 22 and a half grams, 22 kg. So just you can imagine. So even if you have 3 liters of water, 3 kg of water, and 3 kg of water, if you have the same amount of packet in which you are having 3 kg of water, the same substance, if you take the iridium, it will be approximately 67.5 kg. 67.5 kg. So 3 liter and 67.5 is very difference. So iridium has the highest density because the particles of iridiums are heavier and they are very tightly packed. Secondly, if I'm talking about the lithium, lithium has the lowest density. That is, if you take the same ice cube of lithium, that water was having weight 1 kg. So lithium will be having only half kg weight, 0.5. Second, they have very high melting and boiling point. Tungsten is very high, highest in among this one. So just memorize it fast, please.
So what does it say after gallium and?
Cesium, gallium and cesium. Caesium, cesium.
Sir, iridium metal, what is it used for?
Iridium.
Yes.
Iridium is a metal that is very heavy metal, and that is used for making something very heavy in like for example, means it is mostly metals. They're used for different for different purpose. For example, for if we need to make something very heavy, so we'll try to make it for iridium in low space, in less space.
Done. Done.
Done. Okay. So everyone done?
Done, sir.
Mariam, you also? And Mohammed
Yes, sir.
Firdaus? And you, Aisha, you done?
Yes, sir,
Okay.
done.
Okay, so start writing. Done?
Yeah.
Yes, Mohammed Firdaus. Please read your answer and
Iridium is the highest density, which is 22.5/g centimeters, and lithium is 0.5, which is the lowest density.
okay.
Tungsten has the highest boiling point.
Melting point, not boiling. Do it correction. Melting point.
Oh, melting point. And gallium can melt at room temperature or when kept in hand. Metals
Okay.
are malleable.
Gallium
They
and
can be
cesium, both gallium and cesium.
gallium and cesium. Okay.
Okay.
Metals are malleable. They can be drawn to a sheet. Metals are luscious. Metals are luscious, which is shiny. An example is silver. Metals are usually hard, except potassium and sodium, which can be cut with a knife.
Okay. Okay. Yes, you, Mariam, read your answer, please.
Metals have high density. Example, iridium has the highest density with 22.5 gram per centimeter square, and lithium has the lowest density with 0.5 gram per centimeter square. They have high melting and boiling point. Tungsten has the highest melting point, and gallium and
Sir, is
cesium
it
have
cube
the
or
lower.
square?
Okay.
Metals,
Okay.
metals, metals are malleable. They can be drawn into thin sheets, and they are also lustrous, which is shiny. And silver is the shiniest metal. The physical state is solid, but mercury can be liquid in room temperature. And metals are usually very hard, but sodium and potassium can be cut using a knife. They are good conductors of heat and electricity. They are ductile, and yeah.
Okay. Yes, Alvina. Can you tell me that which is the most ductile metal? Ductile and malleable metal. Alvina.
Gold.
Both. Okay. What do you mean by ductility?
Ductility is when a metal can be rolled into thin wires.
Okay. Yes, Zainab. What do you mean by malleability?
In which metals can be drawn into thin sheets.
Okay. Yes, Abdul Kavi. Is Abdul Kavi is there? Kavi is not here. Okay. Aisha, can you tell me that uh, which metal is the metals are generally hard, but which metals are soft and they can be easily cut with the help of knife?
Sodium.
Only sodium.
Sodium and potassium.
Sodium and potassium. Okay. So let's move further. And let's move towards the properties of uh, physical properties of non-metals. Okay. So non-metals are opposite to the metals. For example, if metals are hard, then non-metals are soft. If metals are sonorous, then okay, means whatever. If metals are good conductor of electricity, non-metals are bad conductor of electricity. But here, if I'm talking that there are some non-metal that are going to have some exceptions, and then we need to understood them easily. Okay. Like for example, exceptions in non-metals are there that metals are either gas. Metals are solids, like metals are solid except mercury, which is liquid. But here, if I'm talking that non-metals, okay, non-metals are either solid or gas, solid or gas, but only non-metal that is liquid at room temperature, only non-metal that is liquid at room temperature is, okay, that is bromine. Bromine is the only non-metal that is liquid at room temperature. So we say that if metals are shining, if metals are shining, if metals are shiny, so non-metal should be dull in appearance. But there is a non-metal that is shiny non-metal, and its name is shiny non-metal. Its name is iodine. And diamond. Diamond is actually carbon. Okay. Allotrope of carbon. We can say that it is an allotrope of carbon. We'll understand what is allotrope of carbon. Okay. Actually, in carbon, if atoms are arranged in different patterns, so they start showing different properties. Like for example, in graphite, carbon atoms are arranged like this in a hexagonal arrays. Okay, they are arranged in a hexagonal arrays like this. Okay, like this. So we'll simply say that okay, they are arranged like this way. So here, the nonmetals in this is the structure of graphite. And graphite is able to conduct electricity. And why it is able to conduct electricity? We're going to learn this one in the carbonates compound chapter, the next chapter. Okay. Okay. Now, if I'm talking about the diamond, that diamond is very hard. Non-metals, if I'm saying metals are hard, so non-metals should be soft. They should not be very hard. They can be easily broken. But diamond, which is also an allotrope of carbon. Allotrope means in diamond, the diamond atoms are arranged, carbon atoms are arranged in the tetrahedral structures. In the tetrahedral structure. This is the tetrahedral structure, okay? Like the tripod structure. Like the tripod. The carbon atoms are arranged like this. So they are arranged like this. Okay, tetrahedral structure. So because of that, that is very hard. And in more detail, we're going to discuss this one in the next chapter. In very much detail, we're going to study the structure of diamond. Because carbonates compound chapter, in that chapter, we're going to study this one in detail. So if I'm talking here, one thing is that this two allotrope of carbon, one is graphite, and another one is diamond. Sorry, graphite is previous one. This is diamond. Another one is graphite. They are, this is graphite structure in this. Okay, they are all carbon atoms, but they are arranged in different patterns. So if I'm saying here in very simple manner that this is actually carbon, which is a non-metal, but due to arrangements of different patterns, the arrangement of carbon atoms in different patterns make this change in the physical properties of the carbon atoms. Like due to arrangements in this hexagonal arrangements, graphite is able to conduct electricity. And why it is so, we're going to study in the carbons compound chapter. And due to, if we change the pattern and we change it into the tetrahedral structure, the diamond structure, then it will become, then the same carbon atoms, if they are arranged in different pattern, it make it having different physical property that is going to be very hard. The diamond is very hard that it cannot be broken easily. Okay, while if I'm talking about the metals, non-metal can easily broken, but diamond is very hard, it cannot be broken. Non-metals are bad conductor of electricity, but graphite is an allotrope of carbon, which is good conductor of electricity. Non-metal, according to the rule, if non-metal should be dull, because if metals are shiny, so non-metal should be dull, but iodine is the non-metal that is not, that is very shiny. And great diamond is also shiny. So that is simple reason that you need to understand one thing that about the non-metals, that bromine is the only non-metal that is liquid at room temperature, bad conductor of heat and electricity, except graphite, which is an allotrope of carbon and is good conductor of electricity. They are shiny except iodine. Shiny non-metal means shiny non-metal is the iodine. Diamond is allotrope. So please memorize this one and just need to. Okay, just take the students, just note it down fast in the copy by seeing it. Note it down.
Sir, shiny not metal is iodine or diamond?
Both.
Okay.
Done?
No, 1 minute.
Sir, done.
Okay. So those who have done can leave.
Done, sir.
Bye, sir.
Bye-bye. Take care, everyone, please. And keep
Sir,
revising well, and please do the homework, and moreover do the assessment also. Okay. That's all for
okay.
today.
Thank you, sir.
Bye-bye. Take care.
Thank you, sir. Bye.
Bye-bye. Take care.
Sir.
Bye-bye.